Hi, everyone. I'm Vanessa Sockett. I'm a computer scientist at Lawrence Livermore National Lab. And today I want to talk to you about Singularity Registry HPC, which provides collaborative container modules for HPC. So I want to convince you that this is a very kind of compelling use case. So for example, here we're looking at the UVA research computing documentation, and you see that they had a need to pull containers. So specifically Singularity library, didn't have enough storage, they moved to Docker Hub, and now they're maintaining a collection of containers that their users can pull to the cluster with Singularity. When you think about the larger space of registries and, for example, the distribution container initiative, there are all these public registries. So I mentioned Docker Hub, Quay.io, or self-deployed registries. So I developed Singularity Registry Server. There's also you can self-deploy a Docker registry. The problem is that this use case hasn't really been optimized for HPC, because when you're interacting with these registries on HPC, you have a lot of users that are hugely redundantly pulling the same containers, scattered around the file system, possibly not remembering where they are. They're probably pulling latest, which means that we aren't really doing a good job of knowing what versions of things we're using, which is an issue for reproducibility. So yeah, it's not impossible to be reproducible if you're very, very careful, but it's a lot harder, and best practices are hard to follow, and it's kind of arguable that they're even established in the first place. So how would we provide containers? Well, maybe if you're an HPC admin, you could provide a shared collection of containers. Maybe also you could provide it for your group or your lab. You could also just be a user and decide that you're going to manage your own little collection and keep them up to date, that sort of thing. But we kind of needed a solution so that it would be done in a way so that using containers was easier and reproducible and not so redundant. And so I had this idea, and actually, to be fair, many people came to me over the years and they were hinting at something like this. They wanted something like this that didn't exist. And the idea is that we want to kind of look at the bread and butter of delivering software on a cluster, which really comes down to environment modules. So for example, LMOD is very popular. So I had this idea, maybe we can kind of provide Singularity containers, or actually other container technologies that are HPC friendly, via these environment modules. This was not a new idea. I found this community collections online, which was this, kind of framework that seemed oriented toward an admin. So an admin would be able to define kind of a set of recipes or build specification files, and then build a bunch of containers and provide them to the users. When I looked a little closer, so the idea was that the admin would have this master single config file, and that's where they define all their containers and all the commands to interact. But if you look closely, it doesn't really specify an exact, not just an exact tag, but an exact digest of a container. It doesn't allow you to define really complex interactions with containers. And also, since this is like a single file, every admin is going to have their own special snowflake. So it'd be really hard to work on these, to collaborate on these together. So what's kind of wrong with these current solutions? Well, I thought that they weren't easy enough to collaborate on. They really weren't modular enough. And I didn't think there was enough granularity in really being able to define container versions and interactions. So my goals for developing Singularity Registry HPC, I wanted reproducibility. I wanted to define exact tags and digests to install and load. I wanted it to be easy to use. So you clone the repository, you load it and use it. I don't even want to know that I'm interacting with a container. I wanted a certain level of abstraction. I wanted to have a really complicated command, for example, to run a Jupyter notebook, to just look like a single command to run. And then finally, I wanted automation. So obviously digests and tags change all the time, and I didn't want to have to think about this. I wanted some robot, etc., to handle this for me. Let's jump into this. How does this work? Long story short, I did build this tool, and I think it's useful. So you basically do clone the repository, you cd inside, you install it. This places an executable shpc on your path. Then you probably want to install something, right? So you can explore via the command line, but I would recommend going to this web interface. The URL is at the bottom, where you can browse currently over 200 container modules that are from everywhere, from biocontainers, the brain imaging data standard, Docker, SPAC, Jupyter, NVIDIA, basically kind of the big names when you think of like what you want to run on the HPC cluster. To So here I am in Clio, which is an ASP solver. Since I'm using the Singularity backend, it's pulling with Singularity. I'm then loading the module. I do module use because this is my own personal user and I'm not an admin. I can't add it to like the global module path. I then load the module. That places a quote executable, which isn't really an executable. It's an interaction with a container command, an alias. And then I'm able to interact with Klingo. So I said, oh, dinosaur Vanessa, and then it solved me and it said, yes, Vanessa is a dinosaur. And just as an example of the notebook that I mentioned earlier, this is what it would look like if you need to kind of start a notebook using a Singularity container. You have to think of, binding home and special binds to maybe where software needs to be installed. You need to think of command line arguments like no browser. You need to find a port, the IP address. So all of this can be, kind of packaged into this alias of run notebook. So you don't have to think about it. Okay, so what does this file system registry actually look like? Well, it is in fact a file system registry. So here you're looking at a registry directory, which is in the root of the repository, which is why we recommend installing from cloning the repository. And here you're going to see a bunch of Docker, container namespaces. So for example, if we zoom into one of these folders for bio containers, we now see repositories that are under bio containers on Docker Hub. And then within each one, it's just a container.yaml file. This is an entry in the registry and really all you need to add a container. What does that look like? Well, it has an identifier that identifies like where the container is, for example, from Docker Hub. It'll have a latest tag. So for example, this is the digest for the tag that was determined to be latest by the bot that updates them, which we'll talk about in a second. It also has one or more other tags. So this recipe screenshot was a bit early, but as containers mature over time, they'll have more tags that are available to install. There's also a filter that for the bot, so telling the bot like only consider tags that have versions that start with V. It has also a list of aliases. So this is for a SAM tools container. It's a pretty small list, but this list can get rather large depending on the container. And all of this metadata is what renders automatically into that interface for you to find containers. The bot I mentioned, Binok, was created by a talented developer named Alec, who's doing an internship at my institution this summer. And Binok basically opens a pull request. It can be once a day. I actually have it running just once a week. That basically looks at all of these container unique resource identifiers, finds updated tags and digests, and then opens a pull request for me as the maintainer of SHPC to review and update these containers. So here's what that looks like. Here, Binok is updating a container called Beast2 from 2.6.3 to 2.6.4. You'll see that the list of tags is also growing. And we also have automation in terms of actually testing new container recipes. Does the container pull? Does it build? Can we load it as a module just by applying this label container recipe? Also, Singularity Registry HPC, I think it's really important to have really good documentation. This is actually a little bit of an old screenshot because we have support now for LMOD, environment modules, and then for container technologies, we have Singularity, Podman, and Docker. And coming soon are Shifter and Saurus by user request. So why should you care about this? Well, maybe you also see that there really isn't an established best practice for what is an HPC registry, right? We can pull from OCI registries, but it doesn't really work well for HPC. So this is an interesting discussion to have. What kinds of OCI standards or implementations could better improve using containers on HPC? It could be that you kind of step back and you realize maybe this is the case because the research software engineer or HPC communities haven't historically really interacted that much with OCI. We can do better maybe. So I want to inspire some discussion to think of your use case, think of how you install software, how you interact with containers, and beyond even this particular piece of software, Singularity Registry HPC, what can we do to improve the ecosystem of using containers on HPC? So thank you everyone for having me today. I hope this has been sort of an interesting use case and maybe you're interested in Singularity Registry HPC. I am Vsok on GitHub and Twitter if you want to reach out to chat.
Go on mute. That was really great, Vanessa. I definitely learned a lot. A really exciting program. I just got a couple of follow-up Q&A. I guess a couple of
Sounds
follow-up. One of them was as I was watching the video, watching your presentation, I had a couple of thoughts about extending what is this tool and how does it affect the role between somebody who's running infrastructure on behalf of researchers versus the researchers themselves taking ownership of applications, right? And I was wondering if you have encountered folks using this SHPC project strictly within user land, or have you seen any uptick in folks who are running infrastructure to provide, sort of here's a standard set already of things that are installed via SHPC that you can load through our, shared modules into your account, and then you can extend it even further in your user environment. Have you encountered that, or
so SHPC is a fairly new project. I think I just started it in April, which wasn't that long ago. I have already seen both use cases. So I've talked to kind of people that have heard of SHPC sort of in user land, and they may, for example, just want to use it as their user account to interact with Klingo. That's actually my use case. The other use case is that there's a developer that likes doing a lot of stuff with Rust, so he uses SHPC to quickly, get Rust running. In terms of the other use case, I've also seen that. So there's a couple of centers, I don't have to name their specific names, in the United States and outside the United States, that have wanted an ability to actually kind of pre-bake these containers to provide then to the user base. And their plan is to use a lot of the recipes that are already provided by SHPC, but also to create a lot of custom ones. And there's actually an intermediate step. So if you install SHPC as an admin, you can have sort of this central administrative config that says, okay, this is where the registry files are. These are the container technology we're using. But a user on top of that could still then create a custom config for them to be like, okay, I want to use these, main registry, that my admin provides, but I also want to add my own little registry with my own little custom container configurations. So I've seen both use cases. I don't think it would be correct to say that like one is stronger than the other. I think there's flexibility to choose what you'd like.
That's fantastic. The slightly tangential topic, though, obviously this is meeting our users where they are, right? In terms of using LS modules, and there's a larger philosophical question about how much do you pull an audience into trying new sorts of technologies versus supporting them in where they are today. And obviously SHPC is really meeting those users where they are today. And is that ultimately, you think, the right strategy? And how do we move them to something that is a little bit less tied to technology that's been around for a very long time, to get them to use something that might be a little bit have other advantages, like workflow reproducibility at the workflow level, right? So you have configuration files, and this is great for getting containers into the user space, but it doesn't solve the problem of being able to share your data outside of your environment to other folks. And coming from the life sciences myself, I know you have a background in biomedical informatics from Stanford. Genomics and life sciences is really fairly forward-looking in terms of adopting technologies that are not not home and grown from the national labs and from quite a long time ago.
So just to kind of state first, this is not a project that's associated with a national lab. This is a personal project of mine. It's, just to indicate that's an issue.
That wasn't my intention. I mean, like LS mod, for instance, like modules, environment modules.
So this is an interesting question because you're kind of getting at a couple of things. So being able to run a workflow, that's sort of a separate thing from how you run that workflow. So you could use a workflow software. So you could use Nextflow, you could use SnakeMake, whatever you like, within a container that is provided by SHPC. Right. So those are sort of separate things. In terms of like the question that you asked, that's really a cultural thing. You're asking, how do we take this big base of users that are experts in biology and chemistry and, and ask them to like learn another thing. The problem with technology, and this is like a very kind of philosophical thing, it's always changing. And we either have to constantly ask people that are already overloaded with like the responsibility of knowing their domain of expertise to learn another technology, or we have to find ways to be like, this kind of software, so environment modules, LMOD, that's already installed on clusters everywhere. So maybe we can just harness that and make it easier. It's a little bit of an abstraction, because SHPC is providing complex container commands as like what looks like an executable to the user. Mm-hmm. But if that improves their use case, I think we kind of have to be, it's a balance, right? You can't always force someone to do something new. But on the other hand, if there is something new that is greatly better, then you probably want to slowly push in that direction. And we've kind of been doing that with containers, right? Containers hitting HPC first with like, Singularity and Shifter and Charlie Cloud and now Podman and Saurus, and I could probably keep going. People are learning to use containers. That is becoming more of a bread and butter thing of HPC, but we still, as I kind of said in my talk, we really haven't kind of figured out the management part of that. So you're right that in terms of biology, there are much more kind of sophisticated tools to use in terms of workflows and stuff. And if that's what you choose to do, that's great. But there still are a lot of users that are like literally just like on their cluster. They just have like a script they need to run, and maybe it's a script in a container from their colleague that they need to run. And for them, it comes down to, okay, well, either they're going to run the container, or maybe it's just already provided and they can just like load it and run it. So I don't know if I have a good answer to that question. It's a very complicated question, but I think that it really depends on like the user group that you're talking about, and sort of what the new technology is, that sort of thing.
Yeah, no, I agree. I think and you're spot on in that they are sort of orthogonal constraints. That is a big culture change, and I agree with you.
And you mentioned data management. That's a totally other beast. Like, my goodness.
Absolutely.
Yeah,
absolutely. And obviously, that's a third rail I don't want to touch right now. But I thank you. This has been a great session. We don't have much time. If folks want to find out more, they have this website, singularityhpc.readthedocs.io. Where else can folks find you and reach out to you? I guess you had your Twitter profile here. VSOC at GitHub on Twitter, and is it VSOC on GitHub as well? Great, awesome. Thank you so much, Vanessa.
Yeah, thanks for having me. It was great. And if people go to that link, there'll be a link to the GitHub repository, and probably the quickest way to kind of get in touch with me is just to open an issue. Try it out. Let me know what you think.
Great. Thank you all.
Thanks.